For this next problem, we're going to construct a basic timing device using a block bouncing back and forth between two springs. So imagine that we have two springs here, each with a spring constant K, one attached to this wall over here, and one attached to this wall over here. And in the middle, we have a block that's free to bounce between the two of these over this frictionless surface here. And the separation between the two springs' equilibrium distance is 3 meters, as shown here. Now right in the middle of the 3 meters here is a little switch which connects to a timer over here. And every time the block moves over the switch, in either direction, it sends a signal to the timer telling it that 1 second has passed. So as an extra point of clarification, this switch is 1.5 meters from either spring. So I want you to tell me, what does this initial velocity v0 have to be such that every time the block passes over the switch here, a second has actually passed? In other words, we want to choose v0 such that the time it takes the block to push up against this spring and bounce back to this same spot again will be 1 second. Exactly. So you can put your answer over here in meters per second. Now there's one thing in particular that might trip you up with this problem. If you imagine that this block was attached to this spring, then the block would push against the spring in 1/4 of a period, return to the equilibrium position in half a period, extend outwards in 3/4 of a period, and finally return to the equilibrium position once again after an entire period. But keep in mind that the block is not actually attached to the spring. So this point, where the block extends outward and is pulled backwards by the spring, actually never happens. In fact, the block loses contact with the spring at this point right here when it has maximum velocity at the equilibrium position. So keep that in mind when you're solving the problem. Good luck.